Calculus, the first thing that we look at is this subtopic here, limits. Now I'm going to define limits in a very, very so given the function y is equal to f of x. Okay. So f of x is equal to y. We will say if they ask for the limit as x goes to a number c of f of x, the thing that should come to your mind first is f of c. So look, the notes, the lecturers, whatever, they will use different definitions of the limit. Forget about them. The idea is that this is
Sir, is this the first part of the meeting, sir?
exactly.
Thank you very much, sir.
So what you are being asked to find is f of c. This one, no. Is f of c. For example, the limit as x goes to 2 of 3x plus 1 is going to be 3 by 2 plus 1, which is equal to 7. The only thing that will make other definitions fit in this definition that we have used is find the limit as x goes to 2 of x squared minus 1 over x. I've used 1 again. Of x squared minus 4 over x minus 2. Look, if we went direct here and said 2 squared minus 4 over 2 minus 2, we will have 0 over 0. This case is undefined, we know. This is undefined. So what we'll do is we'll just find a way of having this number substituted in this very function, and the result must be defined. That is what we'll be calling limits. So where it fails to be defined, we'll find a way of substituting without having issues. And once we find that way, that answer we'll find, we'll call it a limit. Now, things to note. Always write limit as x goes to this, whatever you have here, until the part where you decide to substitute c in f of x. I'll come back to this point in our discussion. Let's look at examples. Find the limit a, the limit as x goes to 1, x squared minus 1 over x minus 1. B, the limit as x goes to -1 of x to the power 3 plus 1 over x plus 1. C, the limit as x goes to 2 of x to the power 3 minus 8 over x minus 2. First set of examples. So pay attention here. This is the beginning of calculus. If you understand it, the next part will be easy to understand. And so keep building until we are done with calculus. A, if you look at this A, if you try to substitute 1, you have 0 over 0. But if you look at the numerator, it looks like something can be done to it so that the 0 in the denominator can be cancelled. Note that we can have a 0 in the numerator for as long as the denominator is not 0. The function will be defined. So we have no problem with that. Okay? So we start. The limit as x goes to 1 of x squared minus 1 over x minus 1 is equal to the limit as x goes to 1. We factorize the numerator as a difference of two squares, x minus 1, x plus 1 over x minus 1. So that here you will see that this piece and this one will cancel, and then we'll have the limit as x goes to 1 of x plus 1. Now we can substitute. Where there is x, we take 1, so 1 plus 1 is equal to 2. This becomes our limit. So that's what I meant by you keep writing limit, limit, limit until at the time when you are substituting. When you substitute the x goes to that number, when you substitute it in the function, then you stop writing the limit. So that if you say is equal to x plus 1, x minus 1 over x minus 1, which is equal to x plus 1, which is equal to 1 plus 1, which is 2. Even you don't understand what this is. It's nothing. Just some numbers, some variables mixed until we get to the constant. So this is not correct. You always indicate the limit, until when you find the limit, that's when you stop writing the limit. B. B, the limit as x goes to -1, x to the power 3 plus 1, x plus 1. If you substitute -1 in the numerator and the denominator, you're going to find a 0 in the denominator, which will make things undefined. So what do I do? For the numerator, when we get a 0, that's a polynomial of degree 3. When we get a 0, we call that number a factor. So quickly go to synthetic division, pick the coefficients 1, 0 for x squared, 0 for x, 1 for the constant. Bring down the 1, -1 times 1, we get -1. Add, we have -1. -1 times -1, we get +1. Add, we have +1. -1 times +1, we get -1. Add, we have 0. What we have now is the limit as x goes to -1 is equal to, I'm now confused also. So this is equal to the limit as x goes to -1. Instead of us writing x to the power 3 plus 1, we'll write x plus 1. This one we have used here. We are now writing the factorized form of that, multiplied by this piece here, which is a quadratic now, x squared minus x plus 1 over the denominator, x plus 1. At this point, we can see that this guy and this one will cancel. And then we can substitute directly. So while there is x, we take -1 squared minus -1 plus 1, giving us 1 plus 1 plus 1, which is equal to 3. So that is the limit.
Excuse me, sorry. Before you proceed, I was a bit behind. Why are we using this method?
Synthetic division.
Yes, sir.
So just trying to break a numerator.
Okay.
So it's either you use that one or you use long division.
Okay.
For as long as it's a polynomial of degree higher than 2.
Okay. Then, sorry. And how are we collecting this where we're making x plus 1, then so on?
So can you explain again on B?
You're packing your working. I've seen.
So
You have forgotten how to do synthetic division.
Not really, sir. Just how to collect the rows together.
We have forgotten, sir.
So does that part also carry marks, or you can use a shortcut?
Show all your working. So you must show how you have gotten the factor. In fact, unless you memorized, even you have to do something for you to get this.
So if you've memorized, it's fine then.
So if you memorize the instructions are that show all the necessary working, and it's necessary. So you must show.
Sorry, sir. Can you use the one with since it has cubed? Can you use that other method of a cubed minus b cubed? That's how we arrived to x plus 1. The open brackets x plus 1. Then multiplied by the x squared minus x plus 1, isn't it?
Yes.
Okay.
Except that I don't want to introduce anything new to what you already, because we said, remember, we agreed that we are doing all the topics apart from sets, from functions all the way up to logarithms, so that when we do calculus on those, it becomes easy for us to understand. So using what we know, we are now doing calculus on what we know. So let me now go through the method, synthetic division. How do you pick the x plus 1? If the number you have used here is negative, you have a plus. If the number you use here is positive, you have a minus. And then if you had power 3, the thing that you write here, whose coefficients are these, differs by 1 in terms of the power with the one you divided. So when you have x to the power 3, this function inside will start from power 2, and then power 1, and then constant. If it was power 4, you have power 3, power 2, power 1, and then constant. Always. Don't worry, we still have synthetic division on C.
Okay.
So since the
Hello.
quadratic equation is gotten by this short synthetic division, where is that other x plus 1 from?
The one in the denominator.
The one in the
Or the one on
numerator.
top. No, in the numerator, that's a divisor now.
As in, where did it come from?
So, okay, let me give you a simple example. If you are given to factorize x to the power 4 minus 1, just this, would look for a factor. So suppose this was our f of x. Or since it's a polynomial, our p of x, so that I can remind everybody now. Suppose this is p of x is equal to x4 minus 1. Then they say factorize this. What do? We'll look for a number, so we'll try the zeros of the constant 1. So we try 1, we'll have 1 to the power 4 minus 1. So we'll call 1 a factor. So say we have found the factor 1, pick the coefficients of the polynomial, x4 at the coefficient 1, x3 the coefficient 0, x2 the coefficient 0, x coefficient 0, the constant negative 1. And then drop the 1, start multiplying now. 1 by 1, 1. Do the addition, we get 1. 1 by 1, 1. Add 1. 1 by 1, 1. Add 1. 1 by 1, 1. Add 0. Then now we'll write p of x as a product of the divisor multiplied by this function inside, plus the remainder 0. So the divisor is x. Since it is positive, we'll have x minus 1. That's where we get the divisor first, multiplied by what is inside now. These are the coefficients of the new function, which is, since we have x to the power 4 as the original function, the x has already come out. So we're remaining with 3 x's. So we'll have x to the power 3 plus the coefficient here is 1. So x to the power 2 plus the coefficient here is 1, x plus the plus the constant 1 plus the remainder 0. That is how we factorize a polynomial. So what we did in the numerator is to factorize the polynomial x to the power 3 plus 1 first. So I was trying to remind you of the polynomial.
Now, sir, I've got a question. Not on B, on A. Now, the way we are finding the limits. So how can we test whether they exist or not? Is it possible Oh, not at this level.
Not at this level.
Okay.
Sorry, I'm a bit behind. I don't know. How are we getting the one that we are using to do everything?
So
The
we
device.
are here now. We use try and error method. We try the factors of the constant 1.
Then
any number we find that will give us 0 when you substitute in the whole polynomial is called a factor. And that's the number we use as a divisor in synthetic. So if 1 failed, we would have tried -1. If it failed, we would have gone to other numbers if there are any. And the number we find which will give us a 0.
Sorry, sir. On the is it okay if
we are still on this method. So first, are we okay first with polynomial division?
we're okay, sir.
Yes,
But
we are.
Yes, sir.
on this one, personally,
Yes.
sir, I'm confused. Like,
yes, sir, I have a question. Is it okay if you just you just differentiate differentiate if you just differentiate you differentiate the whole equation and then you replace by like on B there you differentiate it and then you replace by -1. Is it okay if you go that way?
It's not okay. And the method you are using is the method you have in mind
sir,
is
but
Hoppito's rule. Now in mathematics,
yes, sir.
especially at UNS, until it is somewhere in the notes, you're not free to use that thing. Sometimes you can even
Not
get
free to
it
use
wrong.
it.
It must appear somewhere first. But don't worry, it's a good method.
Sir,
What if it's not
sir, I have a
verified?
question.
The other one.
Do you have
Okay, James, finish.
The other one.
Okay. Next.
sir? Do we have numbers that do not have possible zeros?
Where you use
No.
where you use the
Yeah, we can. Yeah, you can.
yes, sir. Like
Yeah.
yes, sir. I was saying you work out
Exactly. You can use it.
That's a method. That's it's the same one. Okay. All right.
Okay, same one. Do we have numbers which don't have zeros? No, not under limit. Anything are given like this, if it has zeros, you get them. If there are no zeros, then it's a direct question. Just substitute and move on.
Okay, thank you, sir.
Now we go to C. C, I want to repeat select division so that it can stick. So we have x to the, if you substitute 2 there, you get 0 over 0 undefined. So what do? I got the numerator. Since I have a number 2, which when I substitute in the numerator, I get 0. I call that 2 a factor. So I can bring in synthetic division where I'll have 2 as the number to use in the division, because when I substitute it in x to the power 3 minus 8, I'll get 0. What next? I get the coefficients of x to the power 3 minus 8. The coefficients are 1 for x to the power 3, 0 for x squared, 0 for x, and -8 for the constant. And then bring in 1, I drop it. 2 times 1, you get 2. We add, we get 2. 2 times 2, we get 4. We add, we have 4. 2 times 4, 8. We add, we get 0. So this is a quadratic. What name did we call it under polynomials?
Spherical.
We called it the quotient. And this 0, we called it the remainder, is it? So I have a remainder and a quotient. And the divisor is this number that you have used here. So now we will write the limit as x goes to 2. The numerator x to the power 3 minus 8 can now be written as x minus, since this 2 here is positive, we'll say x minus 2 multiplied by, the coefficient is 1, and the power, since the power we had 3 here, the power will be 2. So x squared plus, the coefficient is 2, so we'll have 2x, plus the constant is 4, so we'll have 4, over x minus 2, the denominator. And then cancel, so we have this, and that cancel. And then we'll have the limit as x goes to 2, x squared plus 2x plus 4. We can now substitute. Where there's x, we take 2 squared. Where there's x, we take 2 plus 4. This is going to be 4 plus 4 plus 4, which is equal to 12.
Sir,
Hello.
now I understand this. The only question I have is where the coefficients, the zeros. Yeah.
Where are they coming from?
Yes.
So because when you're correcting the coefficients of the polynomial, you correct from the highest degree all the way up to the constant without skipping any. So if you can't see x squared, it means that its coefficient is 0.
All right, thank you.
Now, sir, what about if I use this method? Because x cubed plus minus 8, I just say x minus 2, or open bracket and closed, multiplied by x plus 2 squared, the bracket.
But it didn't give us x squared plus 2x plus 4. It doesn't give us x squared plus 2x plus 4.
It won't give?
No. It will give us x squared plus 4x plus 4.
Sure, sir. X minus 2.
And then x plus 2 squared.
No, x minus 2 squared.
X minus 2 squared. This is x squared minus 4x minus 4.
Minus 4x minus 4.
Minus 4x plus 4.
So there's no other method.
So the middle term is not correct. The other methods are there, but I don't want methods that are memorizable. We have so many things to memorize. So let's keep the memory for identities. Here we solve. So I know there are methods that are used in here where you memorize and then you just plug in. Now, memory may fail you because we can play around with these things. And then you are confused. You don't even know how to bring what you have memorized. Another set of examples. So we call this example 1. We go to 2. Find the limit a, the limit as x goes to 2 of x squared so I want a nice one. X squared minus, okay, let me change here. Let me put 7. Then I say, in fact, I was right. As x goes to root 2 of x minus 2 over x minus root 2. B, the limit as x goes to the limit as x goes to -1 of 3x squared plus 4x minus 1 over 7x plus 3, and C, the limit as x goes to root 7 for x squared minus 7 over x. We change it so it doesn't look like a. We put a negative here. Negative root 7 for x plus root 7. So I have this. This is root negative. Solution. A, if you look at the numerator, if you try to substitute root 2, you get 0 over 0. Undefined. But remember, the target is we must be able to substitute root 2 in this thing. So you model it so that it can allow us to substitute. So the only thing to do here is that since we are dealing with root, let's try to rewrite. Let's try to rewrite x squared as x squared, and then 2 as root 2 to the power 2. Because root 2 power 2 is still 2. And then down x minus root 2. And then difference of 2 squares, because of the minus, we can write the difference of two squares. So say x minus root 2.
Sorry, sir, I didn't
X
understand.
plus root 2.
I didn't understand why you've done that on the numerator. Why you put the squared in brackets.
So we can write the number 2 in any form. We can write it as 2 to the power 1. We can write it as root 2 squared, because root 2 squared is still 2. So since there are so many ways you can write it, we want the one that will help us to sort out the denominator. Since we have an issue with the denominator.
Excuse me, sir.
Mm-hmm.
If we want, we can conjugate.
If you want, you can conjugate.
Okay, thank you.
Thank you, sir.
So then we'll have x minus root 2 down as it is. Then we can see that this piece here and this one can cancel each other. Then now, where there is x, we can replace root 2 plus root 2, so giving us 2 root 2. Let's see what could happen if we conjugate it. Suppose we conjugate it. We would say the limit as x goes to root 2 of x squared minus 2 multiplied by x plus root 2 over x minus root 2 x plus root 2. Let's see if it will work. I just answered before testing. So we'll have x. In fact, we can leave the numerator like that. The effect should come from the denominator. And then the denominator is going to be x squared minus 2. Wonderful. Then this and this will cancel. So we'll have root 2 plus root 2, which is equal to 2 root 2. So you can conjugate. But when you conjugate, make sure that you conjugate if you understood very well how to conjugate. Because I've seen so many, even in the test that I gave you up, where you're conjugating, you find you know the method of conjugation, but you don't know how to use the brackets. You'd end up multiplying only, when you take it up, you'd end up multiplying only maybe by 2 and not by the other x. Then everything is messed up. Okay, let's go to B. B, the limit as x goes to -1 of 3x squared plus 4x minus 1 over 7x plus 3. Let's substitute -1 and see if we have issues. Over, this is giving us 3 minus 4 minus 1 over -7 plus 3, which is -5 plus 3, -2 over -4, which is equal to 1 over 2. So this becomes the limit. For as long as it is defined, then it's a limit. Don't say it can't be. How come? In an exam, they're always simple and hard questions, moderate and sophisticated. So you answer each question in the manner it has come, not in the manner you expected. Then for C,
Sir, so what if you accidentally put the limit when substituting, would they just like not consider it, or it can affect your marks?
That one. Look, the examiner won't do anything to your answer apart from marking it. If it is correct, they'll mark it correct. If it is wrong, they mark it wrong. There's nothing like ignoring what you have written. The assumption of the marker is that you write what you know. And if what you know is wrong, then you get it wrong. So you are punished for anything that is not correct.
Okay.
So avoid mistakes. Okay, then for C, now we have even two methods. You can conjugate.
Conjugate.
Or, so let's conjugate. So say the limit as x goes to negative root 7. But when conjugating, don't even multiply the numerator, just leave it. So we'll have x squared minus 7, and then x minus root 7 over x plus root 7, x minus root 7. Then this will give us a limit as x goes to negative root 7. So we'll have x squared minus 7, and then x minus root 7 over x squared minus 7. To take away, so this piece will take away this piece, so that we now substitute directly. Where there is x, we take negative root 7 minus root 7, giving us negative 2 root 7. So we want to run through calculus without bringing any other method apart from what we have already understood from functions, polynomials, trigonometry, logarithms. If possible, binomial. Where necessary. Next, the limit at infinity.
Sir,
Hello.
may I just take a screenshot of the last screen? Thank you, sir. I'm done. Nasiriza, sir.
Okay. The limit, consider this a fact. The limit as x goes to infinity of 1 over x is equal to 0. I can illustrate here. For 1 over x, as x becomes big, if you are to graph this 1 over x, x can't be 0.
Sir.
Hello?
Sir. So from this question, first, limit as x approaches 3.
Mm-hmm.
And then you write x cubed minus 27 over x squared minus x minus 6.
Keep it. Observe it.
Don't
Just don't
forget
lose it. Keep it nice. So when x is 0 on the y-axis. So you know that 1 over 0 is undefined. So the y-axis is an asymptote. Then, if x is 1, you get 1. If x is 2, you get half. So as if x is 4, you get 1 over 4. The numbers are becoming small. So when you are sketching it, it comes out this way. So it's getting closer to 0, but you never touch there. Because when you're about to touch 0, it becomes undefined. The same thing happens if x is going to negative infinity, because you're going to have this structure. So you still get 0. So we have also that the limit as x goes to infinity, to negative infinity, of 1 over x is equal to 0. So these two facts are going to help us a lot in answering all the questions on limit at infinity. Examples. Evaluate. A, the limit as x goes to infinity of 3x squared plus 4x minus 1 over 1 plus 7x minus 4x to the power 2. B, the limit as x goes to negative infinity of negative 4x to the power 3 minus 3x plus 7 over 3 plus 5x squared minus 7x to the power 4. Solution. A. Since we know that the limit as x approaches infinity of 1 over x is 0, or the limit as x approaches negative infinity of 1 over x is 0, what we would do for these type of questions always is to look at the highest degree of the denominator. For the denominator, look at the highest power of x. So here the highest power of x is 2. We have x squared. So what we'll do is we'll write the limit as x goes to infinity and divide throughout by x squared, both in the numerator and in the denominator. So we'll say,
Excuse me, sir. Can you repeat that statement?
so because we know that the limit as x goes to infinity of 1 over x is 0, and to negative infinity of 1 over x is 0, what we'll do for this type of questions, you always look at the highest degree of the denominator and factor it out for both the denominator and in the numerator. You consider the highest degree of the denominator and have it factored out in the numerator and in the denominator. Since the highest degree is x squared for the denominator, we'll go in the numerator and factor out x squared.
Okay, thank you.
We'll have 3 plus 4x over x squared minus 1 over x squared over x squared 1 over x squared plus 7x over x squared minus 4. And then this will give us the limit as x goes to infinity, of, so you can see this and this will cancel. So we'll have 3 plus 4 over x minus 1 over x squared over 1 over x squared plus 7 over x minus 4. When you reach here, you just pick the constant 3 over the constant -4. Because the limit as x goes to infinity of 4 over x will be 0, 1 over x squared will be 0, 7 over x will be 0, 1 over x squared will be 0.
So,
You know?
just a little bit behind on the just the second last step. I don't know where you've written 1 over x squared plus 7x. And the previous one it was, oh, okay. Oh,
Thank
okay, sir.
Sorry, sir. Just repeat the last statement.
Okay, I'll repeat it very soon in a property. I realized that I needed to list out some properties, so I'll come back to the last statement. When you're done with B, in B I'll mention it, and then we'll go to the properties. So for B, same thing.
So, sir,
Yeah.
it's wrong to write it as -3 over 4.
It's the same thing. Look, -2, even if you write negative somewhere there and you do this, or -1 over 2, even if you say -1 over 2, still the same. You get the point?
Jeffo.
Okay. B, since x to the power 4 is the highest degree for the denominator, we'll have the limit as x goes to -infinity, x4, -4 x3 over x4 minus 3x over x4 plus 7 over x4 over x4, 3 over x4 plus 5x squared over x4 minus 7 x4 over x4. Then we'll have the limit as x goes to negative infinity of the x4 will cancel, and then we'll have negative 4 over x minus 3 over x squared plus 7 over x4 over 3 over x4 plus 5 over x squared minus 7. So this goes to 0, goes to 0, goes to 0, goes to 0, goes to 0. So we'll have 0 over negative 7, which is equal to 0.
Excuse me, sir. There where you've written 3 over x to the power 2, isn't it supposed to be 3 over x to the power 3?
Yes. X to the power 3.
I don't really understand how, since you're factoring out x to the power 4, like if x to the power 4 open brackets negative 4x to the power 3 over x to the power 4, isn't the denominator x to the power 4 going to cancel? Then, as in, why isn't it remaining negative 4x to the power 3, but it's going to negative 4 to the power x?
This is what has cancelled that thing on top.
Which one?
The x to the power 4 in the denominator has cancelled the x to the power 4 in the numerator. So the x to the power 3 over x to the power 4 are facing each other. They have to deal with each other.
I can't get what you're saying.
So maybe I missed your question.
No, you're answering the question. I think you're just too fast.
Okay. That's to be slow. So my point is, since down here we have x4, up here we have x4. The x4 outside the brackets will cancel each other, so that there is no multiplication of x4 with the x4s inside. So each piece, when we have x3 over x4, there's nothing outside that can help cancelling this. So the powers 3 and 4 will have to cancel each other in the manner that from 4, only one will remain. So we'll have negative 4 over x.
Oh, now it makes sense. I understand. Thank you.
Good. Now let me...
Sorry. So 0 in the numerator is okay. This just in the denominator.
Very, very okay. In the denominator, it can't work. It will be very, very complicated. Don't know if you are done.
This type of limit, are the only one that can give us 0, even if it's undefined?
What do you mean by even if it's undefined? Well, this is defined. Zero over a number that is not
what
0
I mean
is
is
defined.
like for the other examples that we had. Oh yeah.
Okay. So now, after having looked at all these, let's get down to the properties of limits. and then we'll bring in some more examples. Property number 1. Property number 1. The limit as x goes to c of f of x plus g of x is the same as the limit as x goes to c of f of x plus the limit as x goes to c of g of x. 2, the limit as x goes to c of f of x g of x is the same as the limit as x goes to c of f of x multiplied by the limit as x goes to c of g of x. There's no harm there. 3, the limit as x goes to c of f of x over g of x is the same as the limit as x goes to c of f of x over the limit as x goes to c of g of x. Now, one thing you should know is that when we say you can get for a numerator and for a denominator, if you get back to this, you can see that we've done that. We took for the numerator and for the denominator separate, so that the limit as x goes to c of a constant a is just a constant a. So the limit as x goes to 10 of 20 is 20, because there's no place of c in that constant. So do examples, don't worry. 5, the limit as x goes to c of the square root of g of x is the same as the square root of the limit as x goes to c of g of x. So the limit is very, very complicated. It can go anywhere. It doesn't care about the bracket. It can enter there in such properties. So to just elaborate some of these, I'll bring in another set of examples.
Sorry, wait.
Okay.
About.
Okay. Evaluate.
Okay.
Okay. I'm gonna say okay. Okay. Find the limit as x goes to as x goes to 3 of 100. B, the limit as x goes to 2 of the root of x squared minus 7. Too dangerous. Root of x squared minus 3 over the root of 4 minus x C, the limit as x goes to 1 of 1 over x3 minus 4. Solution. For A, the limit as x goes to 3 of 100 is equal to 100. For B, the limit as x goes to 2 of the root of x squared minus 3 over the root of 4 minus x. Here, if you want, you can take the limits inside, or you just substitute the numbers. So you say 2 squared minus 3 over 4 minus 2. 4 minus 3 is 1 over root 2. And for C, the limit as x goes to 1 of 1 over x3 minus 4, we substitute. This will be 1 over 1.
Sorry, what was the explanation on the first one?
Since there's no space for the number 3 in 100, you just have 100. It's a constant function, so a constant function f of x is equal to 100, f of 3 will still be 100. So isn't that principle? So here you get negative 1 over 3. Done.
Now sound B. On top there is S1, root 1 is 1. What about there 4 minus 2? How is it 1 over root 2?
4 minus 2 is 2. That's why we have root 2 in the denominator.
Oh, so
Sir.
Hello.
Sir.
Hello.
Is it okay to leave it like this, or we're supposed to take it to the numerator, the rational, whatever?
You're supposed to take it to the numerator, but there's no harm in leaving it there. It's just a limit anyway. Okay. Then, in case this guy appears in your notes, it's also another good way of finding the limits that comes out of 0 over 0 situation. But if you want to use it, you have to mention that by L'Hospital's rule, you mention it before you use it. How do you use it? If you have the limit as x goes to 2 of x to the power 3 minus 8 over x minus 2. If you try to substitute 2 there, you get 0 over 0. So what you do is you get the limit as x goes to 2. You differentiate the numerator. You also differentiate the denominator.
Sir, a second. May I kindly see the previous board?
Okay.
All right, sir. Okay.
So you don't use quotient rule. You differentiate each piece on its own. And then you have the limit as x goes to 2, 3x squared over the derivative of x is 1. Then now you can substitute 3, 2 squared is going to be 3 by 4, which is equal to 12.
So, sir, if you are to use this one, then you need to mention it. You need to state it. To say by
You need to
A
state
or
it.
so.
Yes. If you don't remember the mentioning, it's as good as you haven't done anything.
But it's also
Sir,
recommended.
does this
It's
apply to
okay
all
as
limits?
well.
It's okay as well, for as long as it's mentioned. Not to all limits, only to limits which have 0 over 0 or infinity over infinite situations only.
So can we try this rule with an infinity situation?
Okay. B. Fira, bring up your
What's
question
up?
now.
I found the answer, sir. It's 27 over 6. I had the debate with my colleague.
Okay. Yeah, I knew that you were just jade.
I was high, I was in the zone.
Okay. Okay, so the limit as x goes to infinity of x to the power 3 minus 1 over 2 plus x to the power 3. Or I can even put a 2 here to make a difference. So if you try infinite on top, infinite down, you have infinite over infinite. So then you say, okay, I will differentiate the numerator. It will give us 3x squared. I will differentiate the denominator. It will give us 6x squared. If you substitute, you still get infinite over infinite. So you differentiate again. The numerator you get 6x. The denominator you get 12x. If you substitute, you still get infinite over infinite. So you differentiate again. You get 6 over 12. But you said the limit for a constant is a constant, 6 over 12, which is 1 over 2.
So can you go through again?
So we are differentiating the numerator on its own, the denominator on its own, not quotient rule. The derivative of x to the power 3 minus 1 is 3x squared. The derivative of 2 plus 2x to the power 3 is 6x squared. If you substitute infinite, you have infinite over infinite. So again, you differentiate. 3x squared will give us 6x. 6x squared will give us 12x. If we substitute, again undefined. I mean, we have infinite over infinite, which is undefined. Differentiate again. Derivative of 6x is 6. Derivative of 12x is 12. But properties, the limit as x goes to c of a is a. So a constant limit is a constant. So we get 6 over 12, which is 1 over 2.
Sir, is it the same as multiplying with the highest degree of the denominator?
Factoring out, yes. it will be the same story. So I don't just want you to memorize. Otherwise, before you start solving, you can tell that the limit here is going to be 1/2. You just pick the coefficients of the highest degree if they are equal. So for x3 on top is 1, for x3 down is 2. So you know as I'm solving that the answer is going to be 1/2. But you need to show the weight. So some things will only be nice when you discover them yourselves as you do so many questions. So you discover that for as long as the powers are equal for the numerator and the denominator, and the limit goes to infinity, what will happen is that you always be finding just the coefficient of the numerator over the coefficient of the denominator if the powers are equal. If the power of the denominator is higher than of the numerator, the limit will always be 0. And if the power of the numerator is higher than of the denominator, the limit will always be infinity. But those things, you discover them as you solve. No need to memorize. Just solve quite a good number of questions. Then you realize for yourself that, oh, every time I have this situation, I'm getting this. Every time I have this situation, I'm getting this. That's how we study and prepare for the quiz.
So how come when you use the one with the highest, I mean the highest with the highest degree, the one with the highest x degree, you're getting -1/2, but the other one we've gotten half positive.
There's no one there's a negative.
It's there, sir.
You just made a mistake.
It's there, sir.
It's there.
It's there.
It's there, but it's
Yes.
coming out.
Yes.
Wow.
You've just made the mistakes, you guys.
Oh, sir,
X3?
it's coming out half. It's coming out half, not negative.
1 minus that
It's coming out
over
half.
x3
No, it's half.
to this plus 2. Then this and this will cancel. Then this is 0. This is 0. So we get 1/2.
Sir.
Yeah.
It's a negative.
It's bronze, sir. Too much, man.
We didn't divide by 1 by the x cubed.
Okay, so for now, exhaust this. Try to understand. Go through it. Think about it today, tonight, and tomorrow. Saturday, 18 hours, we'll advance to piecewise limits and sketches, and then we'll start looking at methods of differentiation. The first one being by first principles. So I think for the videos, I'm going to send, don't worry. I'm going to send at an appropriate time.
Sir.
I don't want you to miss class because you know that there's a video.
Okay, me, I don't know how the 6x squared came about.
The 6x squared. So don't mute. I want you to tell me what is the derivative of this thing using power.
Derivative.
I know of 2 plus 2x to the power 3. Yeah. So I know I haven't done these methods. So I was doing that shortcut there deliberate. So when we do the methods of differentiation, here we are using power rule, where we drop for the constant, the derivative of a constant is always 0. The derivative of 2x to the power 3 is 2. Then you drop the 3, then you have x, then from the 3 you subtract a 1. So that you get 6 here, and then you have 3 minus 1 is 2. So I have 6x squared. That's why I didn't want to mention this before we go through the methods of differentiation. But because some people are very uncomfortable without it being mentioned, I had to mention it. So we'll do a lot on Saturday. Please don't miss. Don't miss class so that you get a video. Attend class and attend class. And please feel free to ask as many questions as you want to ask during class so that you don't cry for if there is no video.
Today's class app was awesome.
But sir, Aerospit was made many other style.
Don't worry, because we haven't done methods of differentiation. So first we differentiate.
Hospital, sir, it's very nice, eh? This one.
People.
Because sir, this question which I was telling you about, people were finding wrong answers, right?